In the previous lesson, we studied how to measure angles using radians and degrees. In this lesson, we'll be studying trigonometric functions, or just trig functions. Trigonometry is a study of triangles. Let's take a look at a basic right triangle. If we look at this image of a triangle, we have an angle theta, we have a side adjacent to that angle, and a side opposite angle theta, and a hypotenuse. Now we can label each of those sides x, y, and r respectively. The six trigonometric functions, or just trig functions, is the sine of theta, the cosine of theta, the tangent of theta, and then their inverses, the cosecant of theta, the secant of theta, and the cotangent of theta. Looking at each one with a little bit more detail, we'll see that the sine of theta, looking at our image, is equal to the opposite side divided by the hypotenuse. The cosine of theta is equal to the adjacent side divided by the hypotenuse. And the tangent of theta is equal to the opposite side divided by the adjacent side. On the next line, we have our inverse functions. The cosecant, which is the inverse of sine, is simply the hypotenuse divided by the opposite side. Again, notice that the sine of theta is opposite over hypotenuse, but its inverse, the cosecant, is hypotenuse over opposite. We just flip the fractions. The next function, secant, is the hypotenuse divided by the adjacent side. Again, the inverse of the cosine. And the cotangent is the adjacent side divided by the opposite. Again, the inverse of the tangent. At this point, I would pause the video and study this image and the six trigonometric functions and try and remember them as best you can. You'll be using them over and over again, so they will start to stick after a while. One helpful tool to help remember them is using the old acronym SOHCAHTOA. SOHCAHTOA represents the top three trigonometric functions: sine, cosine, and tangent. Specifically, the S stands for sine, the O stands for opposite, and the H stands for hypotenuse. So sine equals opposite over hypotenuse. The Ka, or CAH, stands for, the C stands for cosine, the A stands for adjacent, and the H stands for hypotenuse. And lastly, as you can probably figure out, the T stands for tangent, the O stands for opposite, and the A stands for adjacent. In this example, in order to learn how to apply these six trigonometric functions, we need to evaluate this triangle. Now we're given two sides. The bottom is 3, and the length is 4. But we need to determine what the hypotenuse is. You might remember from your geometry days that we can do that using the Pythagorean theorem. Specifically, the side x squared plus the side y squared equals the hypotenuse squared, or r squared, which is represented by this equation here. So if we substitute in 3 for x and 4 for y, we get r squared equals 3 squared plus 4 squared. And that's equal to r squared equals 9 plus 16, which adds to 25. Now in order to find r, we need to take the square root of each side. So we get r equals 5. So the hypotenuse is 5. Now we know all three sides of the triangle, we can find the six trigonometric functions. So if we find the sine, we just take the opposite side, 4, over the hypotenuse, 5, relative to angle theta. The cosine is the adjacent side, 3, divided by the hypotenuse, 5. And the tangent is the opposite side, 4, divided by the adjacent side, 3. Now we can find the inverse functions, cosecant, secant, and cotangent, simply by taking the inverse of each function. So the cosecant is the inverse of sine, so we just flip the fraction. Instead of 4 over 5, we have 5 over 4. For cosine and secant, the cosine is 3/5. The inverse of 3/5 is 5/3 for secant. And then cotangent, which is the inverse of tangent, is the inverse of 4/3 or 3/4. Go ahead and pause the video and try this problem. Now the first thing we need to do is solve for the hypotenuse r. We're given the base 15 and the length 8. So using the Pythagorean theorem, we have r squared equals 15 squared plus 8 squared. So r squared equals 225 plus 64. So r squared equals the sum total, 289. And if we take the square root of both sides, we'll get r equals 17. So the hypotenuse is 17, and we now know all three sides of the triangle. Now we can find the 6 trigonometric functions. We know that the sine of theta is equal to opposite over hypotenuse, which equals 8 over 17. The cosine is equal to adjacent over hypotenuse, which is equal to 15 over 17. And the tangent is equal to opposite over adjacent, which is equal to 8 over 15. Now for the remaining three functions, we could simply just flip the fractions to find the inverse. So the cosecant of theta equals 17 over 8. The secant of theta equals 17 over 15, and the cotangent of theta equals 15 over 8. But you should also recognize that the cosecant is equal to the hypotenuse over the opposite, and that secant of theta is equal to hypotenuse over adjacent, and that the cotangent of theta is equal to adjacent over opposite.